Welcome back to General Chemistry mini lecture series, lecture 15, relationship between amount of element and compound. So previously we already learned how to interconverting from the mass of a substance to the particle of the same substance, or vice versa. Today we are actually going to focus on how to convert a quantity of one substance to the quantity of another substance. Okay. For example, we can consider A here as a carbon, B here as a carbon dioxide. Carbon as A, and then carbon dioxide as B. So how do we perform the conversion of quantity between the two? We use subscripts in the chemical formula. For example, 1 mole of CO2 gives 2 moles of oxygen, but 1 mole of CO2 only gives 1 mole of carbon. So we use a subscript as the conversion factor. The coefficients, that's what we are going to talk about later in stoichiometry. So in stoichiometry, we'll use the coefficients of a balanced chemical equation as the conversion factors. Okay. Now let's work on one example. How many moles of hydrogen atoms are in 0.5 moles of water? You see, we are converting from the moles of water, we can consider water as A, and then to the moles of hydrogen atoms, we can consider hydrogen atom as B. Okay, so now we start from what we know. We know the number of moles for water, that's given 0.5 moles, multiplied by the conversion factor. We are converting from moles of water to moles of hydrogen atoms. Okay. And in the conversion factor, we are going to use the subscripts. 1 mole of water gives 2 moles of hydrogen atoms. The moles of water, you see the unit there, they are cancelled. And now the answer is 1 mole of hydrogen atoms. So 0.5 moles of water molecules gives 1 mole of hydrogen atoms. Another example. How many grams of oxygen atoms are in 0.75 moles of sulfuric acid? So sulfuric acid, we start from there. We have 0.75 moles of sulfuric acid. Because we are going to find out the grams of oxygen atoms, so therefore first we need to convert from the moles of sulfuric acid to the moles of oxygen atoms. So 1 to 4, and the 4 is a subscript for oxygen atoms. Now you see moles of sulfuric acid that can be cancelled. And now we further need to convert from moles of oxygen, put that on bottom, to grams of oxygen. And now of course we can cancel the moles of oxygen. And then that should give us 48 grams of oxygen atoms. Another example. How many hydrogen atoms are in 10 ammonia molecules. Okay, so we start from 10 ammonia molecules, and we need to convert from ammonia molecules to hydrogen atoms. One ammonia molecule contains 3 hydrogen atoms. So ammonia molecules, they are cancelled. And then we have 30 hydrogen atoms. So 10 ammonia molecules gives us 30 hydrogen atoms. Another one. How many grams of nitrogen atoms are in 126 grams of nitric acid? Okay, so now assume A is nitric acid and B is nitrogen. All right, what do we know? We know grams of nitric acid, so we need to convert that to moles of nitric acid, and then from moles of nitric acid to moles of nitrogen atoms, then from moles of nitrogen atoms to grams of nitrogen atoms. So that's the strategy. Okay, start from 126 grams of nitric acid, convert that to the moles of nitric acid using the molar mass of nitric acid. Now convert from the moles of nitric acid to the moles of nitrogen atoms. That's 1-to-1 ratio, because in the subscript you see for nitrogen in the chemical formula is 1. Then the last step, we are going to convert from moles of nitrogen to grams of nitrogen using the molar mass. And that should give us 28 grams of nitrogen atoms. Now let's take a look what kind of information can we obtain from a chemical formula. So we use a sodium phosphate as an example. So the first column is different quantities, and the next 3 columns, so they are simply the 3 elements in this compound. Okay, first let's take a look at the number of atoms in each formula unit. So for sodium, since we have the subscript of 3, so therefore we should have 3 sodium atoms. Phosphorus, 1 atom. Oxygen, 4 atoms. Next, mass, the total mass of each element in one formula unit. So then we use AMU as the unit of mass. So since we have 3 sodium atoms, then 3 times sodium's atomic mass, that gives us 68.97 AMU. Phosphorus, only 1 atom, 30.97 AMU. That happens to be just the atomic mass for phosphorus. Oxygen, 4 times oxygen's atomic mass, 64 AMU. So moles of atoms in each mole of compound. For sodium, that should be 3 moles for every 1 mole of sodium phosphate, again because of the subscript for sodium. Phosphorus, 1 mole. Oxygen, 4 moles. Now the number of atoms in each mole of sodium phosphate compound. We know the number of atoms or number of particles that's related to the number of moles. Since there are 3 moles of sodium atoms in 1 mole of sodium phosphate, so therefore that should be 3 Avogadro number sodium atoms, 1 Avogadro number phosphorus atoms, and then 4 Avogadro number oxygen atoms. Now the total mass of each element in grams in 1 mole of compound. There are 3 moles of sodium in 1 mole of sodium phosphate, so 3 times the molar mass of sodium, then that should give us 68.97 grams phosphorus, 30.97 grams, oxygen 64 grams. Okay, let's take a look at the first quiz here. How many moles of oxygen atoms are in 1.5 moles of ozone? So first you need to know the chemical formula for ozone. That should be O3. So now we know the moles of O3 molecule. We just need to find out the number of moles of oxygen atoms. We start with 1.5 moles of O3. We are converting from moles of O3 to moles of oxygen atoms, and in 1 mole of O3 we have 3 moles of oxygen atoms because of this subscript. So therefore that should be 3 here. And of course 3 times 1.5, that should be 4.5 moles of oxygen atoms. So therefore the correct answer should be C. Okay, now you can work on the remaining few questions, and of course many more from the homework assignment. So this is lecture 15, and I will see you guys in lecture 16.